Hello. Today we're going to talk about our exam review for trimester 3. So some of the things you might need to follow along. Well, this is the copy of the exam or sample exam, so you can look at this. Line paper would be good. Graph paper would be good, and of course a calculator. So hopefully you have those things, and let's get started. All right, the first question wants us to take this equation here. Y equals 7 times 4 to the x power, an exponential, and match it to one of these graphs. So one of the ways you might want to try to do, there's a couple ways. First, since you have a graphing calculator available, we can just plug this in. Y equals 7 times 4 to the, oops, I should probably do that, 7 times 4 to the x power. And we're going to graph it. And it looks something, which doesn't give us a great picture, but it gives us something. All right, with just what I see there, with just this, I can eliminate D. D is not the answer. All right, and neither is A. A doesn't look like that either. So we're looking for an upward sloping graph. A couple other things we might want to look at to figure out what is the answer, because these B and C look very similar. All right, the first thing we might want to look at is where this is at when x is 0. Okay, so when x is 0, anything to the 0 power is 1. So when I plug in x, y, x is 0, that's 7 times 1, which is 7. So this looks like it probably crosses at 7, and so does that. So let's try, 1 is definitely going to be quite a bit different. So let's try 1. If I plug in 1 here, that's 7 times 4 is 28. All right, and 1 over here, maybe not the greatest. We could probably try, I'm going to say I'm leaning towards C though, but we could try -1 as well, which would be 7 over 4. Yeah, that's got to be close. It's C. C is the answer. All right, let's move on to the next one. So here's the graph. Here's the representation. Y equals x squared minus 2x plus 4. Identify the number of real solutions. So this one's actually not too bad. Our solutions are where it crosses the x-axis. This doesn't cross the x-axis at all, so there is 0 solutions. Good question. A parabola always has an axis of symmetry. All right, here is an imaginary answer. So x squared equals -1. To solve this equation, we went over this in class today. If I square root both sides, I get x equals the square root of -1 plus or minus. And we learned today that the square root of -1, the answer is I. So I need a plus or minus I, which looks like C is the answer. All right. Simplify the radical expression. This is chapter 11 stuff. The square root of 4n cubed is the square root of 4 times n squared times n. Simplified it. The square root of 4 is 2. The square root of n squared is n. And this other n doesn't get to come out and play. That looks like B to me. Moving on. Here's one. How many real zeros does a polynomial have? 1, 2, 3, 4, 5. To me, it crosses 5 times. C is the answer for that one. If you forgot what the cubic looks like, this is a cubic. If you forget, you could graph all these in a graphing calculator and see which one looks like that. But it is a cubic. All right, next. All right, which of the following statements is true regarding the graph of 1 and 2? This one's a little tricky. So graph 2 is a 90-degree counterclockwise rotation of graph 1. So graph 2 is a 90-degree counterclockwise of graph 1. Graph 2 is a reflection of graph 1 about the x-axis. graph 1 is a 90-degree counterclockwise rotation of graph 2. I think we can agree it's a 90-degree rotation. How it's worded is the tricky part. Oh, can we see that? Let's see if I can get that to focus in quickly. Come on. All right. So, I think we can agree that it is a 90-degree rotation. We just have to figure out from which one to which one. So graph 1 is a 90-degree counterclockwise rotation of graph 2. So if I take graph 2 and I rotate it 90 degrees counterclockwise, that is actually what we're doing here. So again, a little bit tricky. Graph 2 is actually a clockwise rotation of graph 1. So that's what makes that wrong right there. All right. Let's take a look at 9. Where is this negative at? So here's our graph. Here's the you can see the actual line. We just want to know where this is negative. Okay, and remember that 0 is not negative. So the zeros here look like 2 and -1. So we don't want to count those lines. We don't want the equal to. We just want strictly less than. So that's basically asking you, do you know that 0 is not negative? All right. Here we go. Evaluate this function. F of x equals 6 to the x power when x equals -2. All we have to do is take the -2 and plug it into the function. So this becomes 6 to the -2nd, which is 1 over 6 squared, which is 1 over 36. Remember, negative exponents take a number and move it into the denominator or vice versa. Okay, remember, when it has a negative exponent, we move it. It does not make a number negative. All right. Which function is greater at the given value? So y equals 5x or y equals x to the 5th when x equals 4. We just got to plug these in. 5 to the 4th power is 625, and 4 to the 5th power is smaller or bigger, 1024. So we don't know which one's greater. It's 4 to the 5th power is bigger. All right. Population. Suppose a population of 400 crickets doubles in size every 3 months. How many crickets will there be after 3 years? Well, these problems, it's y equals a times b to the x. A is your initial value, so that's the 400. Okay. Times, and then b is what it's doubling or tripling, so doubling. It says every 3 months for 3 years. So you got to ask yourself, how many 3-month periods are there in 3 years? Well, there's 4 3-month periods in a year, and so 4 times 3 is 12, 2 to the 12th power. All right. So that's where I'm going to get my calculator out. I'm going to type this in: 400 times 2 to the 12th power. That is an enormous number. Bam. Bam. So 1,638,400 crickets. That is a lot. All right. Similar problem. So this is a compounding annually problem. Very similar to the first one. So our principal balance. So what are we starting with? 1,700 times the 2%. This is what separates people that really know what they're doing and the people that are just pretending. Remember, if I want to know how much I'm going to have after, let's say, a year, I'm going to have 100% of my original value plus 2%. So 1.02. 2% is 0.02 as a decimal. And after 11 years, that's going to be to the 11th power. And I'm just going to type that into my calculator. And that's going to give me $2,113.74 after round here. And it's money, so you only go to the hundreds place. All right. All right. Degree of the monomial. That is all of the exponents added together. So 4 and 2 is 7. That's a 7th degree monomial. Match the expression with its name. This isn't a multiple choice test, so we're just going to figure out. This is a 4th degree trinomial. 4, the biggest exponent is 4. There's 1, 2, 3 terms, trinomial, fourth degree trinomial. The difference, simplify the difference. Remember, the trick to these problems is to distribute the negative to those signs, so change all the signs in the second set of parentheses and then just combine like terms. Oops, this should be plus 5. Make sure I changed it. It was positive 8w squared, now it's negative. It was positive 3w, now it's negative. It was negative 5, now it's positive. Combine your like terms. I have a 5w squared minus 8w squared is negative 3w squared. I have a negative 4w and a negative 3w, that's negative 7w. And I have a negative 8 plus 5 is negative 3. That is the answer. And that would be a quadratic trinomial if you had to name it. Alright. The sum is actually a little easier than the difference. We just have to add the like terms. You could pretty much just drop the parentheses out. And let me get that to focus one more time. Really struggling with that right now. Alright, so 8u cubed plus 3u cubed is 11u cubed. The biggest mistake people make on these is changing the exponents when you add or subtract like terms. You do not change the exponents. 2u squared minus, there is no other u squared term, so nothing to combine it to. Then we have the minus 4u, and then we have the 7 and the 3 is positive 10. And that should have been a squared. Sorry about that. There we go. Alright. Simplify the product. This is just a distributive property problem. So we're going to distribute. And that becomes 2n cubed plus 6n squared plus 8n. Like bases add exponents, multiply your coefficients. Factoring the polynomial, one of the hints that this is probably just a GCF problem is that there is an x on the end and it's a cube, not a squared, so this is not going to be like an undoing FOIL type problem. We're just going to take out what we can. 2, 4, and 8 have a GCF of 2. X cubed, x squared, and x have a GCF of x, so I'm going to take that out of all of these. And when I take out 2x from 2x cubed, I have x squared plus 2x plus 4. Factors of 4 that add to give you 2. 4 and 1 is 5, and 2 and 2 is 4. So this is prime. You can't factor this. That is the answer. Just a GCF problem there.